Hello friends, in today's video, we are going to see a brand new chapter that is Lambda expression. During Java development and evolution, many features have been added from Java 1.0. Okay, so new features are going to be added into the Java original release. But we have seen the there are two new additions to it. First is your generics and second is your lambda. Okay, generics we have already explained. Now we will see the lambda expression in this video, in this chapter, which is the subject of this chapter. After Java 8, lambda expressions have been added, significantly enhanced Java because of two reasons. First reason is they added new syntax elements that increase the expressive power of the language. Okay, syntaxes means generalized structure, like a class has been having a syntax, particular syntax, method definition having separate syntax, then your interface has been added with some syntaxes like this. Okay, they streamline the way that certain common constructs are implemented. Okay, then second is addition of lambda that we have added. It resulted in new capabilities being incorporated into the API library. Okay, so and they enhance the capabilities and new syntaxes. Among these new capabilities are the ability to more easily take advantage of parallel processing of multi-core environment. Okay, so they enhance the capability of parallel processing. Like we have seen the parallel processing in multi-threading. Like this, it also lambda expressions also enhances the ability to more easily take advantage of parallel processing capabilities. And it relates to the handling of for each style operation, for each style for loop, and the new stream API. Okay, we support pipeline operation on data. The addition of lambda expressions also provided the catalyst for other new Java features. First is default method. It's a method that lets you define the default behavior of the interface method. And the second is method reference, which lets you refer to a method without executing it. Okay, so you are providing the method reference directly, but you are not actually calling that particular method. In the final analysis, it's in the much same way that generics reshape Java, lambda is also reshaping the Java, or it is continuing to reshape Java today. Okay, so lambda expression is the latest technology in today's Java world. Lambda expressions will impact virtually all Java programmers right now. They truly are that important. Okay, so learning and understanding it is important. Okay, what is the default method? Now we will see first what is the default method. Prior to Java 8, an interface could not define any implementation whatsoever. Okay, what is interface? It is only the structure. It is having only interface structure, that is method structure. Okay, so it will not have method definition. All previous versions of Java, the methods specified by interface were abstract, containing no body. Okay, so whatever class that is going to implement the interface will be implementing that methods included in that interface. Okay, that was the traditional form of an interface, and it is the type of interface that the preceding discussions have used. But after release of Java 8, change this by adding new capability to interface called the default method. Okay, so new feature is added, a default method after Java 8. The default method will be included in the interface. So what was the previous interface talking about? It will have only structure of the method, like integer add, opening and closing parenthesis, and semicolon. What is it going to add? What is it going to do in that particular method? It is not defined. Whichever class is going to implement that interface will be defining what that add method will actually do. Okay. A default method lets you define a default implementation for an interface method. Okay. So if no other method is there, the default will be called. Or if the default method is specified and you are calling that default method, the default answer will be found out. In other words, by use of default method, it is possible for an interface method to provide a body and will have the default answer, okay, rather than being abstract. The default method was also referred to as extension method, and you will likely see both terms used. Okay, first the method is called either default method or extension method. A primary motivation for the default method was to provide a means by which interface could be expanded without breaking existing code. Okay, so interface will be there. Its structure will be the same as the previous. Okay, what we will add, what is added over there? Only the default structure, and that default structure will give you the default value, default implementation of the method. But it will not break the existing method structure or existing interface structure. It will be the same. You have to recall that there must be implementations for all methods defined by an interface. If a new method were added to popular widely used interface, then the addition of that method would break existing code because no implementation would be found for that new method. Okay. So if you are, for example, if you are having that interface and if any method you are adding as a new method into that interface, so whichever classes, a number of classes that are implementing that particular interface have to break their code because they have to must implement that method provided by that interface. Maybe it may be a new method or the previous method. Okay, and it would have been breaking the previous code. The default method solves this problem by supplying an implementation that will be used if no other implementation is explicitly provided. Okay, if nothing else found, this will be used. As simple as that. Okay, the addition of default method will not cause pre-existing code to break. You can still use the interface with the default implementation of the method. Another motivation for the default method was the desire to specify methods in interface that are optional depending upon how the interface is used. For example, interface might define a group of methods that act as on a sequence of elements. Okay. One of these methods might be called remove, and its purpose is to remove an element from the sequence. That is remove at particular index like that. So there are multiple methods, for example, multiple methods or a bunch of methods or a group of methods that are acting on sequence of elements. Okay. So sequence of elements, we can take it as array. So if you are going to remove a array value or array element at the particular index, what you will call remove at particular index, and its purpose is to remove an element from the sequence. If the interface is intended to support both modifiable and non-modifiable sequences, then remove is essentially optional because it won't be used by non-modifiable sequences. Okay, so if it is non-modifiable sequences or the fixed sequences, you cannot call remove and on that particular sequences. Okay, and A class that implemented a non-modifiable sequences would have had to define an empty implementation of remove even though it was not needed. Okay, whether or not you are implementing that remove, you are requiring that particular remove method, still you have to implement, or you can left it blank, but you have to include it in your class implementation. That was the previous structure. But today, a default implementation for remove can be specified in an interface that does nothing or throws an exception. Okay. So you can specify remove nowadays the interface that does nothing. Okay. So providing this default prevents a class used for non-modifiable sequences from having to define its own placeholder version of remove. Okay. So whenever you are providing the default method, that will prevent or stop a class used for unmodifiable sequences from it compulsorily define its own version of remove. So it is not compulsory for the class to implement the remove if it is not needed by them. Okay, it is optional for them. For example, optional for non-modifiable sequences. Thus, by providing the interface makes the implementation of the remove by class optional. It is important to point out that addition of default methods does not change a key aspect of interface, inability to maintain state information. Okay, interface is still unable or unable to maintain the state information. Like it cannot have a variable like this. If interface still cannot have instance variables, for example, that the defining the difference between interface and a class is still there. A class can maintain state information, but interface cannot. And it is still not possible to instantiate or create an object of the interface. Okay, you cannot create it like this. Interface name object is equal to new interface. Okay, so all the structure is same like in the previous versions of Java, which have not included the default method. The only addition is default method. All other structure of interface is still the same. Interface must be implemented by class if it wants to instantiate itself. Okay. Even though beginning with Java 8 interface can define default methods, the interface must still be implemented by a class if it is to be instantiated or object of that particular interface is to be created. Okay. As a general rule, default methods constitute a special purpose feature. Interfaces that you create will still be used primarily to specify what and not how. What will be the methods included? What is the structure of this interface? What the method will be returning? Okay, but how it will be returning? What is the inside structure of the method? It is still not defined. Okay, so whatever your interfaces you are creating in the nowadays Java, that is Java after Java 8, there will be still the criteria like they will be used primarily to specify what and not how. The inclusion of a default just adding the more flexibility to the interface. Now we will see default method fundamentals. An interface default method is defined similar to the way the method is defined by a class. Okay. So how we are defining a method inside a class? First of all, return type, method name, parameters or no parameters depending upon your choice. Opening and closing curly braces, and inside that you are writing the structure of what it is doing inside the method. If it is returning something, return type will not be a void. Anything else primitive type, but it is not returning something, then it will be void. Okay, depending upon that. The primary difference is that the declaration is preceded by the keyword default, so that you will understand it is the default. Now we will see the interface with the default method. First is the normal method and second is the default method. First method is a normal interface method. It does not define a default implementation. So it is integer get number. opening and closing parenthesis, and then semicolon. Same way as the previous interface structure. It is the function name is get number, first thing. It has no parameters, second thing, and it is returning integer. Okay, and it is not a default method. Second is a default method. Notice that it provides a default implementation, and how to identify this is the default method. You are preceding the keyword default. Okay, default string, get string, return default string. Okay, so this method will be called if no other implementation will be found. So default is the keyword telling that this is the default method. String is the return type of the method. Get string is the name of the method. My interface has two methods. First is get number, is the standard interface method declaration and no implementations whatsoever. Second is get string, and it is returning string, and it is the default method preceded by the keyword default. Get string is declared by the default modifier. This syntax can be generalized. So whenever you are going to create a default method with the implementation, what you have to do is you have to precede it with the default modifier. Next, now we will introduce the Lambda expression. Key to understanding Java implementation of Lambda expression has two constructs. Okay, so how you will understand Lambda? First of all, you have to take into account two constructs. First is the Lambda expression, that is what is Lambda expression, and second is the functional interface. So now we will start first of all with the Lambda expression. Lambda expression is anonymous unnamed method. Okay, this method is not executed on its own. The first thing you have to remember, Lambda expression is an anonymous method. It has no name. And second is, this method will not be executed on its own. It is used to implement a method defined by a functional interface. Okay. So it is used, or an anonymous method is used to implement another method defined by a functional interface. Lambda expression result in a form of anonymous class. A class that is having no name. So Lambda expressions are also commonly referred to as closures. Okay, so closure is equivalent to Lambda expression. A functional interface is an interface that contains one and only one abstract method. Okay, this method specifies the intended purpose of the interface. First thing you have to remember, functional interface, only one abstract method. One method, abstract means nobody. Second, this method specifies the intended purpose of the interface. So a functional interface typically represents a single action, and it will represent the purpose of the interface. So what this interface is going to do. Okay. So second thing, first was Lambda expression and second is the functional interface. So we have understood both. Lambda is what? An anonymous method, will not be executed on its own. Okay. And it is used to implement method defined by a functional interface. And what is functional interface? It is having only one method that is abstract with no body, and it specifies the intended purpose of the interface. So what that interface is going to do. Okay. The standard interface runnable is a functional interface because it is having only one method, that is run. Run will be implemented whenever you are going to implement the multi-threading. Okay, if you are implementing the runnable class, my class implements runnable. If it is implementing runnable, it is must for you to implement the run method. So it is having only one abstract method, that is run. Okay, so run defines the action of runnable. A functional interface defines the target type of the Lambda expression. Okay, the Lambda, it will define a target type of the Lambda expression. This you have to remember. Then a Lambda expression can be used only in a context in which its target type is specified. So what is the key point you have to remember? A Lambda expression can be used only in a context in which its target type is specified. If target type is there or given, then only in that context only you can use the Lambda expression. So target type should be known. And how to identify the target type? It is given by functional interface. A functional interface is sometimes referred to as SAN type and SAM stands for single abstract method. A functional interface may specify any public method defined by object such as equals without affecting its functional interface status. Okay. So it can add or specify a public method, any public method defined by object class, which is the base class in Java, main class, such as equals. So equals is the public method. So it can, functional interface can specify that public method equals. This is just an example, not only equals, there are many more methods that are public in the object class. So functional interface may specify any public method from the class object without affecting the functional interface status. The public object methods are considered implicit members of a functional interface. Okay, implicit members of a functional interface because they are automatically implemented by an instance of the functional interface. Okay, any public method of the object class that are specified by the functional interface are considered as the implicit members of the functional interface. Why? Because they are automatically implemented by an instance of a functional interface. Now we will see more closely at both Lambda expression and functional interfaces. Now first, Lambda expression fundamentals. The Lambda expression introduced a new syntax element and operator into the Java language. Now hold on. Okay, so what you have to do is you have to take a concentration because we are going to see a new structure, new syntaxes, new syntax elements and operators into the Java language. First is new operator we are going to introduce now. The new operator sometimes referred to as lambda operator or the arrow operator is a right side arrow. The arrow which is pointing to the right direction. It divides a lambda expression into two parts. The left side specifies any parameters required by the lambda expression. So if no parameters are needed, empty parameter list is used. And in the right side, the lambda body. In the left side, optional parameters. If are there, you can specify them. If are not there, they will be a blank or empty parameter list. And in the right side, the lambda body, which specifies the actions of the lambda expression. Parameter, right side arrow, action. Okay. So you have to remember this structure. Left side is the parameter list. If are there, they will be there. Otherwise, empty parameter list, right direction arrow, and actions of the lambda expression. The right side arrow can be verbalized as becomes or goes to. Okay. So parameter goes to actions so that you can read it out like this. Parameter list becomes or parameter list goes to actions. Java defines two types of lambda bodies. One consists of a single expression and other has a block of code. So we will start with a single expression. Lambdas with the block bodies are discussed later. Okay. So now it will be helpful to look at few examples of lambda before continuing. We will see the simple examples. Let's begin with what is probably the simplest type of lambda expression we can write. Okay. So it evaluates to constant value is shown here. Empty parenthesis goes to or defines 123.45. This lambda expression takes no parameters, thus the parameter list is empty and returns the constant value 123.45. Method with no body, method which has no name. Okay, anonymous method, and it evaluates to an anonymous class in the future, and what it results, what it goes to, or what is become, it returns 123.45. Okay, it is similar to the following method. Double my method return 123.45. The method defined by lambda expression does not have a name. For that purpose, we are going only with the opening and closing empty parenthesis goes to 123/45. And it is equivalent to double my method returning 123.45. Here we are having name like in the previous structure of method returning double. But here we are not having any parameter list. A slightly more interesting lambda expression is then opening and closing parenthesis in a blank goes to math.random into 100. Okay. This lambda expression obtains a pseudo-random value from math random multiplied by 100 and returns the result. Okay. So what is the inside structure of this lambda expression is method with no parameter which takes no arguments like in the previous example, and what it result is math.random into 100. Okay. So it will get the random pseudo-random value from the math.random and multiply by 100 and return the output. Okay. It too does not require any parameters. Next, when a lambda expression requires a parameter, it is specified in the parameter list, opening and closing parenthesis. Okay, on the left side of the lambda operator. Likewise, in the method definition, like a simple method definition we have in the previous section, in the previous chapters. What was the structure? Method name in the opening and closing bracket. Any values like integer a, comma integer b, like this. So in the opening and closing parenthesis, we were having the parameter list and it was returning something. So here also we are having the parameter list in the bracket. Okay. So what is the structure over here? Takes the parameter n. So whatever we are specifying as in the parameter. So n can be 2. 2 module 2 is equal to 0. Okay, so it is checking if we are going to going with 2 value, then 2 module 2 is equal to 0. This lambda expression returns true if the value of parameter is even. Okay, so any even numbers 2, 4, 6, 8, 10 will be evaluating to module 2 will be evaluating to 0. And so output will be true. Okay, so like this. So parameter is depending upon us. We can specify any even number, or if we want the wrong result or false result, we can specify the odd number in the parameter here. Okay, if we are here specifying 8 module 2 is equal to 0, true. So it will return true. If we are specifying here 9 module 2 is equal to 1, it is not equal to 0, so it will return false. So depending upon which parameter value we are passing over here, it will give you a result. Okay. Although it is possible to explicitly specify the type of the parameter, in this case, often you won't need to do so because in many cases its type can be inferred. Like a name method lambda expression as many parameters as needed. Okay. So depending upon us, how many parameters we have to structure, we can specify as many parameters as needed. Okay. So we don't have to explicitly specify type of the parameter such as n in this case. And most of the time we will not require to specify the type because in many cases type can be inferred. Now second is functional interfaces. Functional interface is an interface that specifies only one abstract method. Okay. Only one and defines the structure of the or what the functional interface is doing. If you have been programming in Java for some time, you might first think that all interface methods are implicitly abstract. So why we are calling them as the abstract method? It was true before Java 8. The situation had changed. Beginning with Java 8, it is possible to specify a default implementation of method declared in an interface like we have seen in the previous section. Private and static interface section methods also supply an implementation. Okay. So today an interface method is abstract only if it does not specify an implementation. Okay. So how we can call the method as abstract? Only and only if does not specify any implementation, not even default. Because non-default, non-static, non-private interface methods are implicitly abstract. There is no need to use the abstract modifier or abstract keyword. Okay. If you want, you can specify the abstract keyword. Okay. Here is an example: interface my number double get value. So what is the rule that you are having the functional interface? First of all, it should have only one method, that is abstract. Okay. All interface may be abstract in all implementations of interfaces. Okay. But there can be a default implementation after Java 8. So what is the rule? There should be only one method, and that must be abstract. So private and static methods also supply an implementation, as we have seen. So here in this case, my number interface is purely functional interface because it is having only one method, and that is to abstract. Default implementation is not provided over here, so it is purely functional interface. The method get value is implicitly abstract, and it is only method defined by the my number interface. So it is a functional interface, and its function is defined by get value. A lambda expression is not executed on its own. Rather, okay, the lambda expression is not executed on its own. It forms the implementation of the abstract method defined by the functional interface that specifies the target type. So what it does, lambda expression does in short, it forms the implementation of the abstract method defined by the functional interface that specifies the target type. The lambda expression can be specified only in a context in which target type is defined, otherwise it cannot be specified. One of these contexts is created when lambda expression is assigned to a functional interface reference. Okay. How to create a context? How it is created? It is created when a lambda expression is assigned to a functional interface reference. Other target type contexts include variable initialization, return statement, method arguments like this. Okay. So now we will see the example that shows how a lambda expression can be used in an assignment context. So what things you have to remember in this slide is a lambda expression can be specified only in a context where target type is defined. The target type must be defined so that, and second, first is implementation of the abstract method defined by a functional interface that specifies the target type. Reference to a functional interface my number is declared. In this example, create a reference to my number instance. My number, my number. So what is my number? Here we have created interface my number. This is the functional interface. And which method it is having? Double get value. Sorry. Next, a lambda expression is assigned so that to that interface reference. Okay. So interface reference is created like it is not an interface object. Okay. You have to remember this. Interface cannot be instantiated. This is just a reference. How to create a reference? Interface name, then interface reference name, and then semicolon. Next, the lambda expression is assigned to that reference interface reference like this. My number is equal to opening and closing parenthesis goes to 123.45 semicolon. So this is the lambda expression, and is equal to will assign this value, whatever the result, this will be stored into this reference. Okay. When a lambda expression occurs in a target type context, an instance of a class automatically created that implements the functional interface, with the lambda expression defining the behavior of the abstract method declared by the functional interface. So what this line suggests is, when the lambda expression occur in a target type context. What is target type context? Which is provided by interface my number. An instance of the class is automatically created, object is created that implements the functional interface. So any class that is implementing the interface, suppose for example, my class implements my number. So when this lambda expression is created like this, and this line is written, at this point after semicolon, what will happen? Instance of the class will be created, or object of the class will be created, who is implementing the my number interface, which is the functional interface, with the lambda expression defining the behavior of the abstract method declared by the functional interface. So functional interface has given the abstract method. Which abstract method it is given? Double get value. Okay. So when you are creating a reference like this, first of all, what you are creating? My number. Then what you are creating? My number is equal to opening and closing parenthesis goes to 123.45. When you are writing this line, and whichever class that is implementing this my number interface, at that same point only, the object of the particular my class will be created, and structure of the method, that is double get value, will be equivalent to body like this. Like method is returning 123.45. So what is the body of that get value method? It is returning 123.45. Okay. So when that method is called through the target, the lambda expression is executed. Okay. So that particular method is called to the target, then lambda expression is executed, and result is 123.45. Then the lambda expression gives us a way to transform a code segment into an object. So whatever code that you have written, that will be transferred or transformed to that code segment will be transformed to a particular object. Okay. So whenever that method is called, which method? Double get value is called through the particular target, the lambda expression is executed. It will not be executed on its own. What you have to do? You have to first create a reference of the particular functional interface, then assign a lambda expression to that reference. Okay. Then when any class is implementing that particular interface, its object is then created, and then the lambda expression defining the behavior, the lambda expression code, whatever you are going to write after the right arrow will be the body of that functional interface method. And when that lambda expression will be called, it will be called when that particular method, that is get value, will be called through a particular target, then only that lambda expression will be executed. It will not be executed on its own. In the preceding example, lambda expression becomes the implementation of the get value method, which is returning 123.45. Okay. So when we are calling it like call get value, which is implemented by previously assigned lambda expression, my number reference of the interface dot get value. So when we are calling this get value, what is the structure of get value? It is returning 123.45 as of the expression evaluation we have given. Like this, my number is equal to opening and closing parenthesis, right arrow, 123.45. So that will be the body of this get value method, and it will be printed, and it will print the value 123.45. Because the lambda expression assigned to my number returns the value 123.45, and it is the value obtained by get value is called. Okay. In order for the lambda expression to be used in a target type context, the type of the abstract method and the type of the lambda expression must be compatible. Okay. So if you want to use the lambda expression in a target type context, the target type, primitive type, and that lambda expression primitive type or any type, it can be class, it can be anything, they must be compatible. Or compatible means one can be casted to another like this, or they can be same. For example, if the abstract method specifies two integer parameters, then the lambda must specify two parameters in this opening and closing parenthesis, whose type either is explicitly int or it can be implicitly inferred as int by the context. Okay, so it should be available for casting as integer by the context. Okay, the type and the number of lambda expressions parameters must be compatible with the method's parameter, because the whatever structure or the default method definition syntax you are giving in the method in the functional interface will be having the body equivalent to lambda expression body. So this parameter list, number of parameters, type of parameter must be same as your lambda expression evaluation, and any exception is thrown with by the lambda expression must be acceptable to the method. Okay, so it should be compatible. First of all, primitive types should be the same. Second, primitive types, if they are not same, they should be compatible. They should be casted or inferred to an integer in this example. And third one, the number and type of the parameter must be the same. Okay, the return types must be compatible as well, and any exceptions thrown must be handled or acceptable to the method. Okay, so now we will see some lambda expression examples. With the preceding discussion, let's look at some simple examples. Interface my number is created, double get value. Then in the public static void main, we are creating the definition my number, declare the interface reference. And here the lambda expression is a simply constant expression. It is returning 123.45, doing nothing. When it is assigned to a my number, the my number get value method will be equivalent to this body. So its body is equal to returning 123.45. Okay. When it is assigned to my number, a class instance or class object is created in which the lambda expression implements the get value method in my number. Okay. Call get value, which is provided by previously assigned lambda expression. A fixed value my number dot get value. Here a more complex expression is used, mat.random. So pseudo random number will be generated from mat.random. It will be multiplied by 100 and result will be stored. Okay, result will be returned. Okay, so in this, if we are providing this way, the output will be any random number into 100, and double get value will be returning any random as the output of this evaluation. Okay, this called the lambda expression in the previous line. A random number, random value, my number dot get value, and another random value is my number dot get value. A lambda expression must be compatible with the method defined by the functional interface. Okay, if you are returning here 123.03 into string format, and your your functional interface method is returning double. So double and string are not compatible, so it must be double, otherwise it will